Pause an AI video at the perfect frame and it can look like a movie still. Press play and the hand melts, the cup slides through the table, or the camera moves like a ghost with no body. So why can AI make images that look real but still get motion wrong? The short answer is that a picture only has to be convincing once. A video has to keep being convincing while the world changes. This is why AI video feels both amazing and strange right now. Newer systems can create faces, streets, animals, products, and cinematic lighting that look believable, but motion exposes a deeper problem. Video is not just many pretty images. Video is memory, physics, and cause and effect. An image generator can hide a lot. If a hand has one odd finger, maybe you do not notice. If a shadow is slightly wrong, the frame may still feel real. The model only needs one arrangement of pixels that matches what people expect. A video generator makes promises every fraction of a second. That person is still the same person. That chair is still behind them. That ball is still falling. The camera is still moving through the same space. Break any of those promises and your brain notices quickly. Humans are extremely sensitive to motion because we use it to understand the world. We know how heavy objects fall, how fabric bends, how water splashes, and how a body balances. We may not write the equations, but we feel when something is off. A simple way to picture the challenge is a flipbook. If every page is drawn beautifully, but the character changes height on each page, the flipbook fails. Video generation has the same problem, except the pages include lighting, depth, texture, motion, identity, and timing. Many people judge AI video by frame quality. They ask if each frame looks sharp and cinematic, but motion depends on time quality. Does the model remember where things were? Does it know what should happen next? Does the next frame follow from the previous one? The technical phrase is temporal consistency. It means the video stays coherent across time. A jacket should not change buttons. A face should not drift into a new face. A window should not appear, vanish, then return. The world should have continuity. One part of this is object permanence. A real object keeps existing when it is partly hidden. If a dog runs behind a tree, it should come out as the same dog. AI video can struggle because it may be rebuilding appearances instead of tracking a stable object. Identity drift is the character version of the same problem. A person can start with one face, turn around, and come back with different eyes or a different jaw. To a model, those frames may all be plausible. To us, it looks like the actor was replaced mid-shot. Hands are a classic failure because they combine shape, motion, and purpose. Fingers bend around objects. They overlap. They hide each other. They press, twist, point, and release. A still hand is hard enough. A moving hand has to keep its anatomy and its action consistent. If you like explanations that slow down fast-moving AI trends without the hype, consider subscribing. This channel is about understanding the mechanism, not just reacting to the newest demo. Now let us look at why these failures happen inside the model. A common misconception is that an AI video model is secretly simulating a scene like a game engine. In most cases, it is not placing solid objects into a 3D world with exact gravity and collisions. It is generating visual patterns that match what it learned from video data. This does not mean the model understands nothing. It can learn many useful patterns from real footage. It may learn that waves repeat, people blink, and cars roll forward. But learned visual patterns are not the same as a guaranteed model of mass, force, friction, and contact. Imagine prompting a ball to roll off a table. A real ball follows gravity, keeps its shape, hits the floor, and maybe bounces. An AI video may make the ball stretch, float, skip the impact, or pass through the table edge because it is matching appearances, not enforcing rules. Cause and effect is even harder. If a person pushes a door, the door should move after the push, not before it. If a glass breaks, the pieces should come from the glass. AI video can produce events that look related, but the timing or physical connection may be wrong. Camera motion creates another trap. In real footage, the camera has a position, a lens, and a path through space. If it moves left, nearby objects shift more than far objects. If the AI ignores this geometry, the shot can feel like the world is sliding instead of the camera moving. That is why some AI shots have impossible camera motion. The view glides through walls, bends around objects without changing perspective correctly, or zooms and rotates in a way no real camera could. It may look stylish for a second, but the spatial logic collapses. Video models are often very good at texture. They can create skin pores, chrome reflections, dust in sunlight, and film grain. But texture is surface detail. Structure is the stable arrangement underneath. A face, a chair, and a room need structure before surface detail can stay believable. Depth is one reason motion is so demanding. In a still image, a flat painting can fake depth with shadows and perspective. In video, the moment the camera moves, the scene must reveal which objects are near, which are far, and what is hidden behind them. Occlusion means one thing blocks another. It sounds simple, but it is a brutal test for AI video. When a person walks behind a pole, the model has to remember the covered body parts and bring them back correctly. If it guesses fresh pixels, limbs can reappear wrong. Short clips can hide problems. A strange frame may pass before you notice, but longer clips accumulate errors. A tiny change in a logo becomes a new logo. A small hand distortion becomes a melted hand. A chair drifting 1 inch per second eventually leaves the room. This also explains why precise editing is hard. If you ask for the same scene but with a red hat, the model must change the hat without changing the face, lighting, pose, background, and motion. That requires separating objects and attributes, not just repainting the whole frame. Modern tools often use reference images to keep a character, object, or style more consistent. This helps because the model has an anchor. But an anchor is not full memory. It can preserve the look while still getting motion, contact, or hidden surfaces wrong. Another challenge is the training data. The internet contains huge amounts of video, but not every clip teaches clean physics. Videos are compressed, edited, cropped, sped up, slowed down, and cut between shots. The model sees outcomes, but it may not see the full physical process behind them. A real simulator keeps track of state. It knows position, velocity, mass, shape, and contact. A generative video model may have internal representations, but they are not always explicit or stable. Without reliable state, the model can forget what exists and how it is moving. This is why researchers talk about world models. A stronger world model would not only draw what a scene looks like, it would represent the scene as something that persists and changes. It would know that objects continue to exist, actions have consequences, and space has geometry. What we know is that better consistency, control, and physical realism are major goals across AI video research and products. What is still speculative is how close these systems are to a true general simulator. A video can look physically correct without actually reasoning like a physics engine. Sometimes a shortcut is enough. For a talking head, a slow landscape shot, or a dreamy music video, approximate motion can look great. The model does not need perfect physics for every creative use. The weaknesses show up most clearly when objects interact in specific, testable ways. Good stress tests are simple. A hand tying a knot, a spoon stirring thick honey, a basketball bouncing twice, a person picking up one object and placing it behind another. These scenes are not visually fancy, but they demand memory, contact, timing, and physical continuity. Audio adds another layer. Footsteps, impacts, splashes, and speech can make video feel more real, but sound also creates new promises. If the glass hits the floor silently, the illusion breaks. If a voice does not match the mouth, the motion problem becomes easier to notice. This matters beyond funny glitches. AI video is becoming part of advertising, education, entertainment, prototyping, and misinformation. If people assume realistic frames mean realistic events, they can be fooled. The danger is not only fake videos, it is over-trusting motion that was never physically verified. When you watch AI video, do not only inspect fingers, watch relationships. Does the object remain the same object? Does the shadow follow the light? Does the action cause the reaction? Does the camera move through a possible space? Motion errors often hide in relationships, not details. The path forward is not just sharper pixels. It is better temporal memory, better 3D structure, better control over objects, and better physical reasoning. Future models may combine generative video with explicit geometry, learned dynamics, reference tracking, and simulation-like planning. The goal is not a prettier frame. The goal is a believable world. So the next time an AI video looks perfect, wait for motion. A still frame asks, "Does this look real?" A video asks something harder. Does this world keep making sense? If you have a question about AI video or a topic you want explained next, leave it in the comments.